Hey.
Hello. Hey, I'm on the air.
I've never been called Fletcher Tom before.
Oh, wow. Right on. Cool. Fabulous. Well, thank you everyone for joining us here today. Kind of assuming that you're here because of the topic. So I'm curious, are you guys looking into voice lift, or is this something you've experienced and had, I don't know, horror stories? So how many people have tried voice lift before with ceiling mics? With ceiling mics, so it's not many of you, but you have tried, right? Was it a success or failure? It was what?
Traditional cardioid mics, yeah.
But did it work or did it not? It did work. Congratulations. Great. So Shure makes a ceiling array microphone, and that's what's used in the case study that we're talking about today. But it's still a ceiling mic, even though it's very unique. That's still something to be wary of, right? I mean, the mic is up where the speakers are. How do you not have feedback? So that's what we're going to get into today, is this actual use case or case study where we succeeded with voice lift. And when I say we, it's really Tom, who's, what was your role in this project?
Well, I was the designer, and I worked with the client to consult on expectations, first of all, because the client can't expect a voice lift system to be a PA system. So we had to make sure that they understood what we were going to be able to accomplish for them, and they did, because they were already familiar with voice lift systems, and they were already familiar with the beamforming technologies that the Shure 910 had. So that made a huge difference with that part of it. And so my portion was to make sure that we got the right pieces parts, that we got the right documentation, that we had all our bases covered as to how things were supposed to go together, and help the people then that were actually working to do the final programming and commissioning. A couple of them are here today, and we'll talk about that here in a little bit, because as this project was a medium to large size project, it was one of the first ones, and that's why it's kind of a cool case study. And it also was really cool because it was one of the first ones to really be able to use beamforming technology in ways that were different than what you had done, for instance, with your typical cardioid mics, and being able to do the limitations between the speaker and the microphone and the talker.
All right, so do you have any pictures?
I do, yes we do.
All right, so who was the customer and what did they want?
The client was the Union Pacific Railroad at their headquarters. Their headquarters is actually in downtown Omaha, Nebraska, and it is a really unique kind of building. It's the third largest building in downtown Omaha. The building itself houses about 4,100 employees, and they have kind of a gathering area on their second floor, which is not only their dining room and what they typically use it for a couple times a day, but it's a multi-purpose space. And it's really a cool kind of a place because it, as we'll see in a minute, it is reconfigurable as well as being multi-purpose. It's very reflective, and it has a ceiling in it that's very unique. So.
All right, but so what did they ask for? What was the requirements?
The scope is always interesting, and we had talked to them because we'd worked with them on a different project, and we had come into the space, and we had talked about voice lift. And they said, we'd like to do voice lift in this room because it's about 124 by about 62 feet total, with all 4 areas included. And they said, well, we would like to have you design a system for this. And then, lo and behold, here came an RFP that included not only voice lift, but it included presenter wireless mic capabilities. They wanted to use the existing speaker locations. It's a multi-purpose space used every day. They didn't want us to be able to have to take the speakers out of where they already had them. They wanted to be able to manipulate the room from a room combining standpoint. But the piece up here that's really one of the kickers to this was that they wanted to be able to bring telephone calls in and out of these rooms. Now, in working, if you've worked with telephone interfacing, you know that every single microphone ideally would have an acoustic echo canceller on it, which meant that we needed to figure out the rim coverage, to figure out the hardware, to figure out the cost of the project. So it was all kind of a step kind of a thing, but it also included a video component. of the 4 areas of the room, we had 3 projectors. We had bright windows on 3 of the 4 sides of the room. We needed to mount some electric screens where they'd never been mounted before, and we needed to do some really basic input kind of things with it. They also wanted a control system. They had standardized on Extron, which was just fine with us. We had located where where we could put equipment, where they preferred to have equipment, and of course, how they wanted to control the system.
All right, so you said existing speakers. So was these zoned speakers?
They were originally a 70-volt system in 4 70-volt zones, and there was a total of 36 of them. So when we originally said
36 speakers, 36 zones.
36 speakers in
All
4
right.
zones. And
4 zones.
And so when we went into the project, we said, we're not really sure what these are. We're not sure what the dispersion is, but we do know that we want to put some really good quality speakers in here, and that's one of the keys to making this work well.
So for those of you who don't know, to succeed at voice lift, building a mix minus is the key. All right. If I'm in a microphone, if I'm here talking and a microphone is picking me up from the ceiling, well, I don't want my voice to come out of this speaker because we'll get feedback. I want my voice to come out of a speaker in some other zone. So I'm actually just learning this right now that there was only 4 zones, because a room that big, I would think there would have been 16 zones or something like that.
Sure.
So that must have been a challenge.
Well, we originally were told that the 4th area of the room wasn't really a priority. And so because it wasn't a priority, they really didn't want to put money into microphones in those areas. What we found is with the MX-A910, we could actually cover those areas by putting them close, but not necessarily in the room. So we wound up with 28 zones instead of 36 zones. We had zoned a couple of the 70s together into areas where they really didn't need to be individual speakers to accomplish the voice lift. But another unique part of this was that the rooms didn't have full height walls. So we knew, and they knew too, that even with a zoning kind of a multi-divisible room, that we were going to get some bleed through. And that wasn't a huge concern for them. But the walls actually pivoted, and they're kind of unique. They're kind of like the train tracks that you see where they do the switching. And so they had built these divisible walls in a way that they could kind of open them up or close them.
Does that have a pointer?
And so I don't think it does.
These walls right here, they swing. Right?
They swing.
Yeah, it's
and
cool.
So that added a little bit of a challenge to it, but it wound up not really affecting things because of how we were able to do the lobing in the room. It really didn't really affect how the performance of the microphones were. In any case, it was a unique kind of styled room, and as you can see, the window areas were very reflective, so we wanted to make sure that we didn't try and get microphone coverage to the windows where we were going to get reflections.
Did you say how high the ceiling was?
The ceiling itself is an open kind of a unique architectural ceiling that's hung at 14 feet. We had worked with the MX-A910s very successfully for doing conferencing at 12 feet. And so part of the expectations of the system were that we were going to create a design that had the microphones set on little drop poles, little 2-foot drop poles from the drywall ceiling at 12 feet. And the fella in the purple there is Treg Curry. He is kind of all things AV for Union Pacific, and he's the guy that said, you know what, I bet we can take this room and I bet we can make it sound like you're standing next to you, but you're 120 feet away. And that was really kind of the concept that they wanted. They said, wherever you are in the room, we want an automatic microphone to come on, and we want everyone else in the room to be able to hear you just like you're standing next to them. And that's really what we accomplished with this project. So we're here today to say this can be done. It's unique, but it really is effective. And in a large room like this, the beamforming technologies that we have to work with now can accomplish this, and it can be really satisfying when it comes down to being able to be in a room like that where there's a presenter that doesn't always have to wear a wireless mic, where the Q&A doesn't always have to have a pass-around mic, and people can be spontaneous again.
So maybe a little explanation about the microphone. It's one mic in the ceiling, but it gives you 8 steerable virtual mics, sort of like flashlight beams. And we call these lobes. So if you hear us, I think you just used the word lobing or something.
Yes,
I think you even made it a verb.
Right.
That's what we mean. So lobes, channels, mics. You can even think of them as mics. So we haven't gotten to it yet, but how many mics are we talking about? And then with every mic having 8 lobes, what are we talking about?
That was part of the design challenge, because that was part of where do we start with something like this? What do you really need when you're talking about this? And how do you figure out not only how many microphones you need, but how many lobes are you going to need, and how many echo canceling channels then are you going to need? And so this is maybe a little bit hard to see from the back, but it's a representation of the 4 areas with the zones cut out that are the places in the ceiling that are actually open, that have HVAC, that have unique lighting, that have the architectural kind of ambiance to them. And so what we did with that is we said we want this to look good. We also have to deal with some areas that are 12-foot round cutouts where it would be very, very hard to get up within the lighting and the architecture in those spaces to actually hang a microphone, and it would look odd. So first off, we had to kind of decide where we wanted to put them, how many that actually would be in the end, and would those locations be able to give us enough lobes that we got very even coverage. And by drawing it out in CAD, by laying it out and seeing what we can do, especially knowing that we can do a 20 by 20 area very well. The tighter the area that we get, the more gain that we can get out of the speakers. So we also had to look at where the speakers were located, of course, because we couldn't move those speakers, and we didn't want to put a microphone right where there's a speaker. So all of those factors came in to play. We decided 18 was exactly the right number, and then we had to figure out how many lobes we'd need so we would know how many echo canceling channels we would need and how much their DSP would cost.
So you just mentioned CAD. Did you use some other software? You mentioned something on your slide.
We do, and in the commissioning stage of this, there's some things that are really important. Impulse response testing with the reference microphones are very important.
I think we're going to get to that, but I was saying designing.
But designing, the really important, the really key factor to being able to do this is right up front to figure out how many lobes you need to be able to do this. And this is where the Shure Designer program, if you haven't worked with the Shure beamforming series, the 310s and the 910s, the beamforming is wonderful on these microphones. And the Shure Designer will give you the ability to say, how do I want to arrange these? And when you look here, you might not be able to see, but each one of those is a foot. So we can say that at 12 feet, we want to put these microphones, and we can say, here's exactly the kind of lobed coverage that we can get. So we did this for every microphone. We used between 6 and 8 lobes per microphone. We didn't use all 8, but we did wind up saying, okay, here's how this can lay out, how these microphone lobes can lay out, and how some of the overall microphones. So Scott, here's what you have.
Wow.
What we found
but just to explain one more thing. So Shure Designer software is just free software you use for designing, and you're looking at it right now, where you can bring in a floor plan of the room, put virtual 910s on it, and then everything that Tom was just explaining. Experiment, figure out how many lobes you need, where are you going to put the mics, where are you going to aim the lobes. And then when you get done, all your work is done as well. You would then push it out to the microphone and have that work done.
Right. You can see that here, what we found is that when we added the 18 microphones together, that a very good coverage was 70 lobes for this particular room. And they did actually work pretty well within the 4 sections of the room. And one of the original scope things that the client wanted to do is they said, we want to have a presenter zone right up at the front, and we want that presenter to have priority. Well, that's nothing hard to do within a DSP, but it is something that we can do with the 910s, and where the green area is the presenter area. So that presenter can walk all the way up and down that, or several presenters can be in that space, and when they speak, they will override by design and by the client's preference.
Okay. So with the time that we have left, you wanted to talk about other factors besides the microphone, and then getting into the telephony, and so how did that go?
There's some great things that we did within Designer, but I think one of the most important things was that all in all, when we went through the whole system, the amount of programming that this took was over 600 virtual blocks. We used 3 bi-amp to Sarah server AVBs that were interconnected, and we chose those because we could write one program and have everything in one program versus writing multiple programs, one for each server box, and then having to tie those together. We had over 2,000 virtual connections in this particular thing, and with the way that the bi-amp server is, that there is a limit to the amount of processing power. And so we actually took the filtering based off of the impulse response that we got from the room resonance and from the speaker response, and we used about 90% of what we had available in the DSP on each one of the 3 units. And that was really interesting. The other thing that was really interesting was that in the end, we would put typical filters in to optimize that audio system exactly the way it needed to be. Really based on that impulse response kind of information. But when it came down to it, we wound up with a curve that looked very different than what you would normally expect to see a curve on this type of a microphone, and that's represented on the right.
EQ
the EQ curve. Now, that's where the Shure engineers and the bi-amp engineers helped us a lot. Ward Wasmer over here, he worked for a Lavella brand group. They were repping at the time both Shure and bi-amp. Ward had some experience in doing some voice lift, and he was a wonderful help. So part of this is, don't feel like these kind of projects are going to be over your head. You're going to get some help from some guys who might be your rep, the guys from the factory that have done this before, and they can give you some of these little tricks of the trade, like this EQ curve, to help make it a success. And in the end, when you see that client, his face light up and say, this really works like it should, I can be clear across the room and you sound just like you're standing right next to him, then it makes sense for them to have said, we wanted to start this project, we wanted to finance this project, and now we have what we're looking for. And you as an integrator, as a designer, as an installer, you can look back on a project like this and say, this is successful all the way around, and when we went into this, we'd never done it before.
But again, with what little time we have, surely something went wrong, or something was
There were a couple little things, and little things like the client decided that they wanted to recess the rack into the wall. The client decided that they wanted to pull some of the cabling themselves versus having us do it like what we had actually won the project with. We found that the way that the ceiling was constructed, that it needed significantly more reinforcement to support the screens. Little things, the typical things that you run into in a project sometimes. So in the end, we wound up with great documentation. We did the things that we needed to do to help their people do the cabling, to help their people calculate how big of a space they needed to actually recess into the wall for their racks. And we wound up with a system that covered that room and did exactly what it needed to do, with that awesome kind of help that the Shure designer will give you, that the techs, the people who support you guys every day, can help you go to the next level with and teach you things with. You just have to have the confidence to be able to say, you know what, I'm going to take on a project like this, because it can be successful if you do it right.
Great. I hope we have some time for some questions. Is that true? Anyone? Well, until they stop us. Questions? Yep, and you're going to really need to speak up. Right. So to recap, this was what, like 120 by 60 foot room or something with a 14-foot ceiling. The mics were hung at 12 feet. So what's the concern? Basically distance from the mic. And any room that's going to have that tall of a ceiling is going to be a very live room. So that's, again, what is going to, it's going to give you pause to go, can we even do voice lift? But really, the technology that's in this ceiling array microphone enables it. You would not be able to get away with this with, I'm not sure how high your ceiling was with cardioid mics, but the ceiling array mic isn't a cardioid mic. It's more directional than a shotgun mic. And then you saw, all the lobes and all that. So that's what enabled this to be. And so the ceiling height is a concern, but not a limitation.
Right. And one thing to your point about that is that if you've studied how much amplification you can get in a room, there's what's called PAG-NAG for typical microphones. And PAG-NAG is that distance between the talker and the speaker and the microphone. And we, with the technology that has been brought to us with beamforming microphones, we can bend that. We can actually get more gain than what PAG-NAG would tell you could. So that is just huge, and it does help in a situation like this, because if you've got fairly controlled dispersion and you've got quite a few speakers, you can start that amplification much sooner as far as the number of feet away. I wouldn't plan to try and do this in a small room. It doesn't work quite like that, but in a large room like this, it can be fabulous, and it's something that usually we don't see. You're one of the few exceptions that's done it with traditional microphones. With beamforming microphones, it works great. You can do it, and you can rely on these guys now that have got a lot more experience with it to say, here, I can make you a successful integrator when you give it a whirl.
Yeah, really quickly, just as a starting point, if you use a PAG-NAG calculator, which you can find on the internet and all that, the MXA910 will give you 6 to 9 dB more gain than what that PAG-NAG calculator would tell you a cardioid or an Omni mic would give you. So, any other questions? All right. And then what about, as a recap, what did you learn?
What did I learn? I learned what we do as a professional integrator is very important. You have to have great expectations with the client up front. You have to talk to them about what your design will actually provide. You need to be able to provide the right documentation, how it goes together. This becomes very complex. You want to have the documentation to make it work, and so we wound up with quite a bit of documentation on this project. We want to make sure that everything that goes in is high quality, including, everything from the telephone interfaces and everything that goes along with this. But I think really one of the main points is that we learned that we can rely on some people back at the factory, back at Shure, and in our case this time back at Biamp, that could help us do things that we probably would have really struggled with along the way. And it made the project go the way it should have. It made the client very happy, and it was a huge success. And we proved that it could be done.
And if you're in Omaha, well, I guess you won't hear the voice lift, but you can go into the cafeteria. It's a public space, but I don't know if they leave voice lift on and all that. Anyway, thank you very much, everyone, for your time. I hope this was informative. And come and talk to us if you'd like to know more.